67 caught my eye because it has a little difference. You notice how it has like a sine and a cos in it, but fortunately it has a sine squared. So you can rewrite that as 2 times 1 minus cosine squared x plus 5 cos x is equal to 4. So I expanded out you had the sine squared, which is 1 minus cosine squared, then distributed the 2 across it, and I just like to bring everything over the other side to have my highest powered term be positive, because I think it's easier to factor with. I'm going to mess with the factoring because this can take time consuming, but I think that worked out. So we got 2 cosine squared, we got minus 5 cosine x plus 2. So we're in business. That actually was surprisingly easy. All right, good. Anyway, so what do we got here? We got cosine x is equal to 2, and cosine x is equal to 1/2, because that all equals 0, and you should always have the 0 over there. Right. Anyway, so this guy ain't gonna happen. And then this one, it just kind of goes back to the old unit circle. Where does the x value equal 1/2? Well, that would be pi over 3 and 5 pi over 3. Because remember that cosine is positive in the first and fourth quadrant. So that's 1/2 there. Pi over 3 plus or minus pi over 3. Now, question 79, there's a whole bunch of printing up here, but anyways, it says solve the trigonometric equation and demonstrate that its solutions are the coordinates of the maximum and minimum points. Okay, so basically, this is what you're going to do next year. This here is called a derivative, and so what a derivative does is it is the slope. So if the slope does something like that, the slope of the tangent line there is 0, the slope of the tangent line there is 0. This would be a maximum, that would be a minimum. So the max and mins for this solution, or for this equation, are going to come from this. This is the slope. So wherever this equals 0, that corresponds to the points where it's at its highest and lowest point. And so, anyway, it even says that right down here, calculus is required, but what the hey. Anyway, so let's go for this equation. That's what we want to do, is factor out a sine x. And then we've got 2 cos x minus 1 is equal to 0. And then we get sine x is equal to 0. And we get cos x is equal to 1/2. So sine x is equal to 0 gives us 0 and pi. And then cos x equals 0. Cos x equals 1/2 rather. That's the same as the question before, pi over 3 and 5 pi over 3. Now, here's kind of a neat little thing. It's like this number line game. Let's see if we can make it work. See if this makes sense. So, if you look here, you see how the slope is positive? Here the slope is 0, and here the slope is negative. So if the slope goes from positive to 0 to negative, you got yourself a max. If the slope goes from negative to 0 to positive, it's a min. And that's a thing called the first derivative test. Well, let's just try this out. All right? So we've got 0, we've got pi over 3, we got pi, we got 5 pi. And let's just see if we can figure this out. Now, if I'm at 0, the cosine of 0 is 1, so this is positive. So the sine curve goes like this. It goes, so to the left of 0 it's negative, and to the right it's positive. So the derivative, this function here, would be negative on this side. So this would be a plus. And then after pi over 3, sine is still positive. This term would become negative, so this would be now negative. And then at pi, this thing goes from positive to negative, so it's going to be back to positive, and then it's back to negative. So if all's well, if you look at the graph, this would be a min at x equals 0. And it would have a max at x equals pi over 3. And then it would be a min, and then a max again. No, the minimum and maximum values are the value of the function. So you'd have to plug those back into the given thing. So like, for example, at 0, if you plug 0 into f of 0, oops, I don't know what's happening there. F of 0, just to plug it in, would equal 1. F of pi over 3 would be, would equal what? It would equal 3/4 plus 1/4. No, cosine of pi over 1/2, right? So it would be slightly larger, which makes sense because it would be a maximum. All right, so that would be what? That would be 2, so that would be 5/4. And so that would be your relative max. Anyway, enough babble. The bottom line is, take the equation, set it equal to 0.